Here's one. How about the 43rd differential of sine? Right? If y is equal to sine of x, what is the 43rd differential of sine of x? Right? What is the 43rd differential? So does that mean we need to take the differential 43 times? Let's hope not. But we'll start from scratch. So we know that the differential of sine of x is cosine of x dx. Right? That's just a basic rule. So the second differential of sine of x is the differential of cosine of x dx. And the derivative of cosine is negative sine, so this is negative sine of x dx squared. Okay, the third differential of sine is simply the differential of the second differential. Of x, which is the differential of negative sine of x dx squared, and the derivative of sine is cosine, so this is negative cosine of x dx cubed. And then the fourth differential of sine, well, it's the differential of the third differential, which is negative cosine, so this is equal to the differential of negative cosine of x dx cubed, and the derivative of cosine is negative sine, and the negatives cancel, and so look what happens. We end up with sine of x dx to the fourth. So what does this tell us? Not what the 43rd differential of sine is, but at least that every fourth differential, we come back around to sine again. There's a periodic nature of the derivatives of sine. So that means that, right, if I take the derivative 4 more times, so that would be, take the differential 4 more times, so that would be the 8th differential of sine of x. Well, if we take the 5th, we'd go to cosine. Take the 7th, we'd be to negative sine. Take the 6th, would be negative sine. Then the 7th, we'd be negative cosine. And finally, the 8th, we'd come back around. And so we'd be at sine of x. Of course, my differential of x keeps going up, so it'd be dx to the 8th. Again, do it for another round. Say 12 sine of x is just sine of x again. And now my differential's gone up 4 more times. So that's 12. And we can say dot, 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 do this a bunch of times. Well, I can do it 16, 20, 24, so on and so forth. But that tells me that the 40th differential, right, that's doing these cycles of 4 10 times. So the 40th differential would be sine of x dx 40. And now we want to know what the 43rd is. Well, d 41. So it's the derivative of sine. That's cosine. And the differential will go up by 1. Do it again. The 42nd differential of sine. Well, it's the derivative of this, so that's equal to So cosine goes to the minus sign, so minus sine of x, and it's the 42nd dx. And finally, the one we wanted to know, the 43rd differential of sine of x is the differential of this function, which is minus cosine of x dx to the 43rd. So that is what the 43rd differential of sine is, and thankfully there's a periodic structure to it, and so it was fairly straightforward to compute. So say we know the position of a particle, so its position at any given time is given by 1 minus 1 over t squared. Say for t bigger than or equal, or actually bigger than 0. We want to know what is the acceleration. Right? This is the position of our particle at any given time. What is acceleration? Well, acceleration is the second derivative of s with respect to t. So, differential of s is the differential of 1 minus t to the negative 2, which is equal to the differential of 1 minus the differential of t to the minus 2. Exponent or power rule, so this is minus 2 t to the minus 3 dt. That's what so this would be our velocity differential, right? The differential of s, that's associated with our velocity. So the acceleration is the differential of that. So the second differential of s is the differential of negative 2 t to the minus 3 dt. Again, power rule, so this comes down, becomes our coefficient. So it's 6t, and what's our new power? It goes down by 1, so that's minus 4 dt squared. So what is acceleration? Acceleration, you take the differential, the second differential of s, divide by dt squared, and we simply get that it's 6t to the minus 4, or if you like, 6 over t to the 4th.